Screencast number 4, incline with friction. Here's my physical principle being used, Newton's second law. And here's a diagram I drew to help me figure out acceleration, to find my x and y coordinates and my force vectors involved. Now, as far as solving for acceleration in the x direction, I have minus the force of friction plus the force of weight sine theta equals mass times acceleration, which gives me minus force of friction plus force of the weight sine theta divided by mass equals acceleration. For the y direction, we have the normal force minus the force of weight cosine theta equals mass times acceleration, which overall equals 0 because the block is not flying off the slope in the positive y direction. That is solving for acceleration of the incline. Here's the solving for acceleration decline with friction. Once again, the physical principle being used, Newton's second law. Here's the diagram I drew to help me figure out my force vectors from my x and y coordinates. Start off with the y direction. We have the normal force minus the force of weight cosine theta equals mass times acceleration, which once again equals 0 because the block is not flying off the slope in the positive y direction. Here is the formula I use to figure out acceleration in the x direction. I have the force of weight sine theta minus the friction force equals mass times acceleration, and solving for acceleration, just divided everything by the mass, which is the force of weight sine theta minus the force of friction over m equals acceleration. That is screencast number 4.